Welcome back, guys. A lot of my students have been requesting that I must do this question paper, which is from Limpopo. And then it was the March exam for last year. As you can see, it was written on 18 March 2025. So on this video, we're going to go through it. If you want this question paper, you can check the description box there. You can first download it and try to do it by yourself. And also, if you are looking for specific questions that you need to tackle, you can check also the description. I've written absolutely everything there. So without further ado, let's just quickly start to tackle this question. So our question one, it starts with this 1.1 which says that solve for x. The first question is worth 2 marks. So these are the easiest marks, guys, that you can be able to get in maths. If you don't understand this, I've also made a playlist for grade 10. You can go and just revise this if you have forgotten. So you're going to apply the zero factor law. We're going to say x plus 3 is going to be equal to 0, or 2 minus x is going to be equal to 0, perfect. So you're going to have x, we take this one to the other side, is going to be -3. Or from here on, we can do this in different way. We can take this one to the other side. It's up to you, but I'm preferring to take this to the other side. It's going to be 2, which is equals to x, So therefore, we can conclude that x is the same as when it is like this, So these are our first solution for that question. Moving on to the next one. So the next one, if you pay attention to this question, this is an inequality question which is worth 3 marks. How can we solve this? It's very, very, very easy. So I'm going to open 2 brackets just like this one. And then after that, we're going to look for the factors of 15 that when we add them or subtract them together, it's going to give us this -2 that is there. So you're going to have x and you're going to have x. So the factors of 15 is 5 and 3. So it's going to be 5 and 3. So now we just have to put the sign in a way. So if we say -5 plus 3, it's going to give us -5 multiplied by this is going to give us 15, and then when we subtract them together, it's going to give us -2, So after that, we need to remove this inequality. So we're going to just say CV, or critical point, or critical values. It's up to you. So we're going to say x minus 5, which is x plus 3 is equal to 0, So then here we can apply the zero factor law. X is going to be equals to 5, +5, or x is going to be equals to -3, perfect. So since now we find our critical value, so we need to represent this in we need to write this in we need to represent our answer graphically, So there's 2 methods to do this. It's either you do it with that other method of drawing a graph, or that one of drawing like a number line, but I prefer to do it using this graph, So I'm going to draw my graph just like this. So -3 is going to be here, and yet there's going to be 5, perfect. So here we're going to select, you can do it in any way that you like, So then they're looking for the values that are positive. So this question, guys, is the same as f of x when it is greater than 0, You're looking for the value of f of x when they are positive. So this inequality things, guys, is the same as graph interpretation. So remember, f of x is the same as y, And then I want you to notify this. If your teacher has taught you a different way to do this, and easiest one, you can pick it, But I always prefer this because this method is also help you to understand how to interpret graphs, So we were looking for the positive values of y that are positive, So since this one is the y values and the x values, where is the graph, the y values, where are they positive actually, So they are positive here at the top, which is this side, and also this side. So if you pay attention to the middle side here, the y values are negative on this side, The only way that they can be able to be positive is outside of that kind of stuff. So it means that our answers are found when x is less than -3, or x when it is greater than 3, perfect. So x is going to be greater than or equals to 5, or x is going to be less than or equals to -3. So this is how we solve those kinds of questions. Let's move on to the next. So going to 1.2, so they say given x plus 3 and blah, 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 perfect. So 2.1, they say for which values of x will x plus 3 divided by x will be undefined, you know. So when they talk about undefined, this thing in your calculator, you might find it as error or yeah, something like that, or math error, something like that, you know. So they're looking for values of x that when we substitute them here, you know, when we substitute them here and we put it in our calculator, it's going to give us undefined. Which are those kinds of x values that we are going to find? So to find it, you need to understand one thing. If we have a fraction, let's say we have 1 over 2, if we want to make this fraction undefined, if we can say 1 divided by 0, we're going to get undefined or error, you know, perfect. But if we say 0 divided by 2, we're going to get 0, you know. So it means that each and every time for any fraction to be undefined, the denominator has to be equal to 0. You know, perfect. So this is the same analogy that we're going to use for this question. In order for us to get undefined, this fraction, this denominator has to be equal to 0. So this one is for 1.2.1. So the square root of x plus 5, it has to be equal to 0. If this is equal to 0, if we have x plus 3, which is divided by 0, this is going to be undefined regardless of the x values that is going to be there, you know. So with this is going to help us to find the value of x. So here we're going to square both sides to remove the square root. Going to square this side, and then when we square, you're going to be left with x plus 5, which is equal to 0, and then we can take x to the other side, which is going to be -5, you know, perfect. So here we got -5. Let's just try to substitute it into 5 plus 5. You know, we're going to get undefined. This calculator I'm using, guys, the way that is said that undefined is said complex infinite. So this is undefined if we substitute -5. So this is the correct one. But I want you to be very careful. They say for which values. In other words, it's not the only one value. There are many of them. You know, there are many of them. So how can we find the rest, you know? So to find the rest, I will advise you to use the number line to understand this. So the first value that we have here, we have -5, né? And then yeah, there's -6, -7, -4, -3, you know. So I'm just going to use our calculator to just find those kinds of missing numbers. So if we take out our calculator, which is this one, we try to put the numbers that are greater than -5. We put -4, for example, and we'll put -4 there. We're going to get -1. It does not give us undefined, you know. And if we when we try -3, for example, we're getting 0, we're not getting undefined. So it means that each and every, you can try this in your calculator, each and every x value that is greater than or equals to that is greater than -5, actually, you know, that is greater than -5. It's not going to give us undefined, no matter what, no matter which number that is greater than -5, we are never going to get undefined. So let's just try the one that are less than -5. If we try -6, for example, we put -6. Here we're getting undefined. This calculator, guys, so this it means undefined based on this kind of calculator. You can use your casual there. Try to put -6, you're going to get undefined, and try to put -7 also in your calculator, going to get undefined. So it seems as if like each and every time when we substitute any number that is less than -5 or equal to 5, because even when we substitute -5, we're still getting undefined. It seems that each and every time when we do that, it's the only way that we're getting undefined, you know. So it means, therefore, we can conclude that the x values that are giving us undefined are where x is less than or equals to -5. So this is going to be your answer for this question. Moving on to the next. The next one, they say solve for x for this one. So let me just rewrite this quickly. Here, to solve for x, I'm just going to cross multiply this. You can make this a fraction, and then this multiplied by this, we're going to have x minus 3, which is equals to the square root of x plus 5. We just cross multiply them. And the next thing here, we're just going to like square both sides. So I'm going to square this side and also square this side. Perfect. From here on, here I'm going to just like open these brackets like this so that I can be able to expand it a little bit. And then this square root, this square is going to cancel this square. We're going to be left with x plus 5 on the other side. And then x multiplied by x is going to give us x squared. So negative 3, x multiplied by negative 3 is going to give us negative 6. Oh, this is positive, guys. Now this is positive. Now my bad. Yeah, this is positive. Yeah. So it's going to give us positive x squared. I'm just doing it fast here because we're going to multiply. Let me just do it slow so that everyone can be able to be accommodated. Yeah, let me just do it slow. Let me not just rush things. We're going to have x squared and then plus 3x plus 3x because we multiply this with this one, and this and that one. And then this is going to be x3 multiplied by 3 is going to give us 9, which is equals to x plus 5. So you're going to have x squared. This is going to give us plus 6x plus 9. And then we'll take this one to the other side. It's going to be negative x and negative 5. And we're going to be equal to 0 there. So we're going to have x squared. And then 6 minus 1 is going to give us plus 5x. And then 9 minus 5 is going to give us 4, which is equal to 0. And then we can be able to finish this one here actually. So I'm going to open two brackets just like this, which is equal to 0. So what are the factors of x? What are the factors of 4? The factors of 4 is going to be 4 and 1, that when we subtract them together is going to give us 5. So it's going to be positive and positive here. So here we're going to just apply the 0 factor law. X is going to be equals to negative 4, or x is going to be equals to negative 1. Perfect. So these are our answers. Remember, whenever we're doing the square root equation, there have to be a certain solution at the end. We need to test our answers in other ways. So if you go and test these two numbers there in your calculator, you will find that x does not give you 1, so it means therefore we can conclude that the x it can be equals to 4, but x it does equals to negative 1. If you test this, you take this negative 4 and then you substitute here on the value of x, it will not give you a negative, it will not give you 1. But if you take negative 1 and substitute it on the x, it's going to give you that 1. So we're going to reject that one. There's going to be a mark for a selection for this one. So let's move on to question 2. So question 2, it carries 12 marks. So yeah, let's first start with 2.1. So 2.1, it says that given the following geometric series, so given a geometric series, and then they say they're giving us this pattern, this series that is there, 2.1.1, determine the value of r, the common ratio in terms of x. In other words, you don't have to like look for the value of x here, perfect. So we probably know that when we are looking for the r, which is the ratio, I take term 2 and we divide it with term 1, perfect. So what is our term 2 here? Term 2 is this one, and then we divide it with this one. So if you can pay attention to this question, remember also we can be able to get r even if we take term number 3, we divide it with term number 2. We're still going to get the same thing. So I just want to avoid the fractions here. Like another thing I can be able to advise you when you are writing question papers, always seek for the easiest way to solve a certain question, because time there is your enemy, perfect. So I'm going to take term number 3, term number 3 and divide it with term number 2, because that one I'm going to avoid fractions. So I'm going to take 6x and divide it with 12. This one is going to be very easy. And then if you say 6 divided by 2, it's going to give you 1 over 2x, So this is the same even if you write it like x over 2, Anyway, it's going to be the same. But this is going to be our ratio for now. So let's look at the next question. So the next question, they say if x is equals to 4, determine the sum of 10 terms, So let me just first remind you of the sum formula. So the sum formula is as follows. So in order for us to find the sum, which is here, we need to have the value of a, the value of r, and the number of terms that are there. So if we can be able to first label that, and then we are good to solve our question. So what is our first term here? Our first term. How can we find the first term? So since now they've given us the value of 4 here of x, and then we can be able to say 24, which is divided by 4, we can get what? The first term. So 24 divided by 4, we're going to get what? We're going to get, if you put this in a calculator, we're going to get 6. So it means that our a is equal to 6, because to find the first term, we're just going to substitute that 4 there. Perfect. And another thing that we need in order for us to find the sum, we need the ratio. Remember, our ratio is this one that is here, is equals to x over 2. But the value of x, we do have it here, is 4 over 2. And then our r is going to be equals to 2. So our r here is equal to 2, and then the number of terms, if we read this, could say determine the sum of the series of 10 terms. It means we have a sum of 10 terms. Perfect. So it means that now we have absolutely everything to find the sum that we are looking for. So we're going to say sum of 10 terms is going to be equals to a is 6, and then our r is 2, and then our n is 10 minus 1 divided by 2 minus 1. So if you patch this in your calculator, you're going to get 6138 as your answer. So let's move on to the next. So our next question, they say the sum of the first n terms of an arithmetic, I want you to underline that, of an arithmetic is given as, so they given us the sum of an arithmetic as a formula. They didn't give us the actual number of the sum, but they given us the formula there. Perfect. So they say calculate the sum of the first 15 terms. So this is the formula that we have here. We're just going to say sum of 15 terms. Whenever there is n there, we're going to substitute this 15 squared plus 8. We substitute this 15. And if you work this one out in your calculator there, you're going to get negative 105. So this is the sum of what? Of 15 terms, negative 105. So the next one, they say calculate the value of term 15. So I want you to understand this. A lot of my students, I saw them struggling with this type of questions. When we talk about the sum, we talk about the addition of certain terms. For example, if we have a pattern like 2, 4, 6, blah, 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 up until there, When we talk about sum, we talk about the addition of all these terms that are here. If we add it, to find the sum of one term, so we're going to add the first term is going to give us 2. And then the sum of 2 terms, so we're just going to add 2 plus 4, which is going to give us 6. The sum of 3 terms is just going to be the addition of this, which is going to give us 12. We're going to add what? We're going to add 2 plus 4 plus 6, which is going to give us 12. So when we talk about the sum, we talk about the addition of what? Of the terms that are there, if you don't know that. Perfect. So why do I talk about it? I just want you to see. If we want, for example, if we want to find term number 2, let's say we don't know term number 2. How can we find term number 2? We can be able to find it, term number 2 of yours, it's always going to be the same as when we take the sum of the first 2 terms and minus it with the sum of the first 1 terms. In other words, whenever you need a term number and you have this formula, let's say you need term number 3, you're going to say sum of 3 terms minus sum of 2 terms. The sum of what you're looking for minus the sum of 2. Let me show you that these things is valid. So let's say we take this pattern as an example. The sum of 2 terms here is 6 minus what? The sum of one term is 2. So if we subtract this 2, we're going to get 4. And this is term number 2. And this term number 2 is 4. And even here, term number 2 is what? Is 4. So we can conclusively say whenever we need any certain term number, if we have this formula of sum, we can be able to use it to find the missing term that we are looking for there, Perfect. So now here we are looking for what? Term number 15. Term number 15. To find term number 15, we're just going to find the sum of 15 terms minus the sum of 14 terms. We can be able to find that one out easy. So the sum of 15 terms, we already calculated, it was 105, negative 105. Né? So now we are going to look for the sum of 14 terms using that formula. So we're going to substitute 14 here, minus 8, we substitute 14 again. So if you work this one out in your calculator, you're going to get negative 84. Perfect. So now we do have the sum of 15 and we do have the sum of 14. So just going to substitute here. Sum of 15 is negative 105 minus. Remember, this minus is for the formula, So the sum of 14 is negative 84, just like this. Perfect. So if you work this one out, you're going to get negative 21. So it means that term number 15 is equals to what? To negative 21. Moving on to the next. So the next one, they say if the first term of the series is 7, which term of the series will have the value of negative 169? Remember, guys, I just want you to remember this. We are given the sum here, a formula that is equals to negative n squared minus 8n. Let me just recheck it. Yeah, a plus, plus 8n, like this, And then here they've given us term number 1, which is equal to 7, Perfect. So how can we find the term that is equal to negative 169? Remember, guys, to find these kinds of questions, the same as the one that they ask you, which term will be equal to negative 169, If we have this Tn, let's say we have nth term here, let's say we know it was 2 plus n minus 1, difference is 3. We can just take this number and substitute here and look for that kind of term number, the number of terms. Perfect. If we can be able to have something like this, which is the general formula, we can be able to find that kind of term number that is equals to 169. So what can we do here in order for us to find it? What is lacking actually? What is preventing us to find that? So if you remember very well, this formula goes as follows. It says a plus n minus 1 and difference. And then the first term, they already given us here, which is 7. And then the difference is the one that we don't have. If we can be able to find the difference, then we can be able to take these 4 marks very, very easy. How can we find that kind of difference? Very, very easy. Since we're given the sum here, we can find the sum of 2 terms. Like actually, we can find term number 2. How can we find term number 2? If we can find the sum of 2 terms, then we're going to substitute 2 here to this formula, plus 8, we substitute 2, and then if you work this one in your calculator, you're going to get 12, Perfect. And then, now that we have the sum of 2, to find term number 2, we're going to say sum of 2 minus sum of 1, The sum of 2 is 12. The sum of 1, remember, the sum of 1 is the first term. Remember when I showed you with, I just erase it, but we talk about it just previously, just before this one, that the first term is going to be, and sum, it means addition, So if this one is the first term, it's going to be the sum of 1. So I'm going to minus it with 7, because the sum of 1 is 7. So if you subtract this, there you're going to get 5. So it means that T1 is 7, T2 is what? Is 5, actually, not 2, Perfect. So if we have this, we can now find the difference. 5 minus 7, you're going to get negative 2. So this is going to be our difference. So now we do have what? We do have the value of D actually, which is the difference that we were looking for all along, perfect. So how can we simplify, how can we solve the question? We know that our Tn now is equal to what? Is equals to, the first term is 7 plus n minus 1, and the difference is negative 2, So to find the value that is equals to negative 169, we can just simply substitute this 7 plus n minus 1 over negative 2. So there is a lot of ways, guys, to solve this question to find the value of n here. But the one that I like, which I think is easy, is to take 169, take 7 to the other side, this 7 to the other side, and I'm going to have negative 7, which is equal to, here I'm going to be left with n minus 1, negative 2. And then this one, if you work this in a calculator, negative 169, let me just confirm it. It's going to give you negative 176, which is equals to n minus 1, negative 2. And then we can divide both sides by negative 2 and the negative 2 on the other side. This is going to cancel this. And if you divide these two, you're going to get 88 on this side. And then they are going to be left with n minus 1. And then now I can take this n to the other side. So I'm going to have 88 plus 1, which is equals to n, So therefore, my n is going to be equals to 89. So the term that is equals to negative 169 is 89. It's term number 89. So therefore, we can conclude that therefore, is term number 89 that is equals to negative 169 as our answer there. So moving on to question 3. So question 3, it starts with this. We are given this sigma notation whereby they say k is equal to that thing that you see there. I don't have to read it out. So 3.1.1, they say determine the values of x which k converges, So remember, guys, for a series to be able to be a convergence, the value of the ratio, let me just write it down, the value of the ratio has to be between 1 and negative 1, if the ratio is between negative 1 and 1, and then that series is going to converge, But first of all, here we don't have a series, but we're given the sigma notation. Remember, on a sigma, let me just give you a quick review. So on a sigma notation, the values of the things that are here are what we call our nth term. We use it to find the term number or something. That this is a subject of the formula of the series that we are having, So the number that is going to be equals here is the starting term. When you put it here, you're going to get term number 1, and then you go and get term number 2. And the term that is here, that is going to be there, is going to be the last term, the ending term. When you put it there, you're going to get the last term. And when there is an equal to something, so this is what we call the sum, perfect. So k here is the sum. The sum of this is equals to these things that is here, perfect. So it is very, very good for you to understand this before we start. So they say determine the value of x for which k will converge. We need a series first, So here they say the starting term of ours here is 1. So it means to find the term number 1, let me just, to find T1 is going to be equals to x minus 1 when we put 1 there at the top, perfect. So plus to find which is term number 2, and we also have to find term number 3. So term number 2 is going to be x minus, not plus, minus 1 squared, and then plus term number 3 is going to be x minus 1 cubed, perfect. So what we need mostly is not all this. We need the ratio. We need to show them the ratio first. So our ratio here, as you know, that the ratio is equals to term number 2 divided by term number 1, So our term number 2 is x minus 1 squared, which is divided by x minus 1. So this thing that is at the top, this is the same as x minus 1 and x minus 1 divided by x minus 1. So as you can see, 1 is going to cancel out. Our ratio is going to be equals to x minus 1. So since now we find the ratio, remember the question needs for the values of x where the series would converge. For a series to converge, the value of r has to be between 1 and what? And negative 1. Perfect. So the value of r, we have it, is equals to x minus 1. And then we're just going to substitute there. So we're going to say negative 1. And then r is x minus 1. And then 1. So now we're just going to solve for x. So we're going to take this negative 1 to the other side and also to the other side there. So on this side, we're going to have negative 1. This one's going to be positive 1, x. And then 1, this one's going to be positive 1 on the other side. This one's going to give us 0. And this one is going to give us 2. So our values of x that can make this kind of series converge are found between 0 and 2. Why don't we have 1x values? The reason is because they ask for values, not the value of x. It means values. It means there are more, So they are found between negative 0 and 2. Between 0 and 2, actually, So moving on to the next question. So they say calculate the value of k when x is equal to this, So now they've given us the value of x. They want k. Remember, the k, we say this is the sum of the series. In other words, they are looking for the sum right now, Perfect. So this sum is going to be the sum of infinity because we have infinity there at the top. And to find the sum of infinity, if you have forgotten, it is this formula, a over 1 minus r. In other words, we need the first term and we need the r, Perfect. So our r, previously we said that it's going to be x minus 1. And what will be our r if x is equals to 2 over 3? So we're going to say substitute this 2 over 3 because the value of x we have it here minus 1 there, So if you put this on a calculator, we're going to get negative 1 over 3. So it means our r is negative 1 over 3. What about our first term? We said here that the first term is equals to x minus 1, So it means also even our first term is going to still be the same. Our value of a is going to still be the same because even here we're going to say x, we substitute this one and we minus it. It was going to give us negative 1 over 3. So with that being said, we're going to find the sum. So we're going to have negative 1 over 3 divided by 1 minus. Remember, here I'm putting don't forget the brackets there. Why? Is because it's going to help you to get the correct answer. So if you work this one out in your calculator, you're going to get negative 1 over 4 as the sum of infinity of this pattern. Remember, I want you to remember this. The convergent series is the only series that we can be able to find the sum of infinity of. The divergence one does not have the sum of infinity. Why? Is because it does not end, Perfect. So let's move on to the next question. Okay, so now let's just take a look at this 3.2, which is the number pattern question. So yeah, this one, guys, it is worth 5 marks. That's a lot of marks, So you need to be very, very, very careful to this type of questions. They say, an air traffic control tower with 11 horizontal support is constructed at an airport, So these towers, those kinds of stuff whereby the airplane is landing on. Let's say there is an airplane here that is going to land in this side. So this is the horizontal support where the airplane are landing from, Perfect. So they say it has been constructed with 11 horizontal support. Horizontal support, they're talking about these lines. I will call, maybe it's the, I don't know what I will call them. Are they still, like, what do they call this in English actually? In Tsonga they call it timanzi kumbe tinsimbi to karhi leti nga veketeliwa laha ma swi twisisanyana. Yeah, so unfortunately not all of you understand Tsonga. I'm Tsonga, by the way. So yeah, I don't know how do they call this in English, but just know that these things, they are constructed, what can I call this, man? I don't know. in Tsonga, in English. I don't know actually. Yeah, but yeah, hopefully I hope you understand. The horizontal support are those kinds of that they use, the method that they have used to construct that kind of an airport control, perfect. So here they said the front view of the tower is shown in the diagram below. So this is the front view of the diagram they've showed us, the front view of that kind of tower. They said the length of the bottom horizontal support is 70. The length of the bottom horizontal 70 centimeter long and it is secured to the ground. So in other words, that saying the bottom horizontal support, which is this, is 70 centimeter, the bottom one that is there. And then they say each addition support is shorter than the one below. So as it keeps on going up, it's going to be shorter and shorter and shorter all the time, perfect, as you can see there. And then they say the length of each horizontal support decreases with a constant difference from each other. In other words, they're giving us a clue that this is going to be a arithmetic pattern actually, perfect. So they say if the top horizontal support is 50 centimeters, the top one is this one. Remember the bottom they say 70, the top is 50 centimeters, which is this one. Which horizontal support has the length of 58? So they want the one that has 58. If here is 70 and it keeps on decreasing, which one that will have a 58 centimeter along these horizontal supports that are here? So what I always try to explain to my student with this type of questions is that when you want to tackle them, first what you must ask yourself whenever you're given this question is that the question that must come to yourself is that what is my first term here according to this statement? What is the first term actually? So if you read it very carefully here, they said the bottom one is 70 centimeters. So it means that the first horizontal support they have installed is this one. In other words, our term number one is what is this one, which is 70 centimeters. So our term A is going to be 70 centimeters. Another question that I want you to ask yourself whenever you're dealing with this type of question is to understand which pattern is this, or what is the difference if it's the arithmetic, if this is the geometric, what is the ratio? So here they've given us a look about the constant difference. It means the difference is what we are going to look for. And then what will be our last term? They've also given us our last term here, or they've given us term number 11. Why do I say this is term number 11? Is because they say this air traffic control tower, it has 11 horizontal supports. So if this one is a horizontal support number 1, this is going to be horizontal support number 11. So term number 11 is going to be 50 centimeter. But the difference, we don't know the difference there. So they want the one which term that will be give us 58 centimeter. That is what they are asking for in this question. So since now we are able to transform this into a pattern, now we can be able to form the general formula or general term. So our Tn here is going to be equals, the first term is 70 plus n minus 1, and the difference, we don't know the difference, but we can be able to find the difference. Why? Using what? Using this clue that they've given us here. They've given us term number 11. In the question, they didn't specify that this is term number 11. They just say that the horizontal support that are here are 11, and the top one, which is the last one, is 50 centimeters. So we can assume that this term, the 11th horizontal support is going to be 50 centimeters, So since we know it, we can be able to substitute this 50 here, which is going to be equals to 70, and then plus, and then n is going to be, since this 50 is term number 11 minus 1, And then we are looking for the difference, because once we find the difference, we can be able to find which term that is equals to 58 centimeter. Perfect. So we're going to have 50, which is equals to 70, plus this is going to be 10, and when we multiply it with this, going to be 10d. Perfect. So we're just going to say 50 minus 70, which is equals to 10d, and then 50 minus 7 is going to give you negative 20, which is equals to 10d, and we can divide both sides by 10, divide both sides by 10. Perfect. So if you divide both sides by 10, this is going to cancel this. Your difference is going to be equals to negative 2. So now we do have the difference. We do have the first term. It means now we can be able to rewrite our new equation. So our new equation is going to be Tn, which is equals to, the first term is 70 plus n minus 1, and the difference is negative 2. Just like that. Perfect. So we're looking for which a horizontal support that is going to be equals to 58. So we're going to say 50, we're going to write 58 there, and 70 plus n minus 1 and a negative 2. So we're going to take 70 to the other side. It's going to be negative n minus 1. Remember, guys, there's a lot of ways to solve for n here, but I prefer this one. So I'm going to divide both sides by, okay, let's not just divide first. Let's just simplify this. 58 minus 70 is going to give you negative 12, which is equals to n minus 1 and negative 2. So I'm going to divide both sides by negative 2 and negative 2. And then this one is going to give us 6, and then n minus 1, that's going to be left. And then we're going to take this one to the other side, and it's going to be equals to 7. Moving on to question 4. Now we're going to functions, guys. This is one of my favorite topics. It is very, very, very easy, So they say consider the function f of x, which you can see that this is an hyperbola. So they say write down the equation of asymptote. So the equation of asymptote here, we know for the y values is going to be remain the same. It's going to be negative 1. But the x values, the way it is here, just going to take this one to the other side. It's going to be positive 1, and with that we are done with the first one. They say calculate the intercept with the x's. In other words, they're looking for the x and the y intercept. So we can start with the y intercept, because the y intercept is the cheapest one. So when we're looking for the y intercept, we're going to let x be equal to 0, and so we're going to say whenever there is x, we're going to put so we're going to look for f of 0, which is negative 2 over 0 minus 1 minus 1. So if you went and punch this in a calculator, you're going to get positive 1, So the coordinate is going to be 0 and 1. And then we're going to move on looking for the x. We're going to let y be equal to 0, perfect, to look for the y in x intercept. So we're going to put 0 here, and we have negative 2 x minus 1 minus 1, perfect. So from here on here, we can do this in many ways. We can take this 1 to the other side, so it's going to be positive 1, and you're going to have negative 2 over x minus 1, So just going to cross multiply. Next, I'm going to just finish it here. So if we cross multiply these two, this and this one to the other side, we're going to have x minus 1, which is equals to negative 2. And then we're going to take this one to the other side. It's going to be positive 1. And then our x is going to be equals to negative 1, perfect, because this is going to be negative 1. Then our coordinate is going to be negative 1 and 0, So for that, we can take the 3 marks. Let's go to 4.3. So 4.3 said, on the diagram sheet provided, draw the graph of f, show all the asymptote, the intercept with the axis. So here's the diagram that they're talking about. So our asymptote there, let's just go back and one back, is y, which is negative 1, and x, which is equals to 1. So we're going to have y, which is -1, is going to be somewhere here. Oh, there is no -1, so it's going to be somewhere here. Let me just draw it. And the x is going to be, x is -1 also. Let me just check. Or x is 1 for the asymptote. So it means for the asymptote, it's going to be this one. It's going to go on this side. And then our x is going to be equals to 1. Now I just first draw the asymptote. Yes, the asymptote has to be those kinds of dotted line. So now I can be able to like put my x-intercept. So the x-intercept here is -1 and 0 and 0, and then the y-intercept is 0 and 1. This is the y-intercept that I have. So then I'm going to like just put it. So 1 is going to be somewhere here, and then -1 of x is going to be, look what I'm doing right now, it's going to be somewhere, it's going to be somewhere here, you know. So this graph, it can go something like this and this, and then the other one is can go in this side. And with that, we are done sketching our graph, you know. So 4.4 says determine the equation of axis of symmetry of f with the negative gradient. Guys, hopefully by now you know this. If you don't know this, I also made a playlist in grade 10 about this kind of stuff, you know. So when we're looking for the equation of axis of symmetry of negative gradient, we're going to use this equation, which is -x plus c. So to find the value of c there, we're just going to sub the coordinate where the asymptotes meet. So the asymptotes meet somewhere here. So the coordinate is going to be 1 and -1, you know. So I'm going to substitute it there. So here I'm going to substitute -1, and here I'm going to substitute 1 plus c. And then when I take 1 to the other side, it's going to be 1 plus 1, which is equals to c. c is going to be equals to 0 on the other side, you know. Yeah, c is going to be equals to 0. And then my new equation is going to be y, which is equals to -x. It's unnecessary for me to write 0. So this is going to be the equation of axis of symmetry with negative gradient. So now we're moving to question 5. So they say the sketch below a graph of f of x, which this one, f of x, is the parabola, and then g of x, which is the straight line, you know. And then they say graph of f has a turning point at a. So this is the turning point of the parabola. And then graph of f and g intersect at a and b. We can be able to see that a and b is the point of intersection. So the first question, they say calculate the numerical value of k, the y coordinate of a. So the y coordinate of a, that is them, we cannot be able to like find it by using the parabola because we don't have an equation of a parabola, but we can use the straight line, you know, because this is the point that passes through this straight line that is here, you know. So to find this value of k, we just have to substitute x where in this equation that is there, you know. So to g of x, this is going to be 5.1, you know. So to g of x, we're just going to substitute 3. So it's going to be g of 3, and then -3, we substitute 3 here, plus 20, you know. Perfect. So if you went on a calculator page, you're going to get 11. So this is going to be 11. So therefore, we can conclude that k is equals to 11. So going to second question, they say determine the range of y, which is equals to -f of x. So here I want you to pay close attention to this graph because it's a little bit tricky by how they've put it here. So if we can be able to take a look at our graph of f, it is a sad graph. In other words, the value of a here is less than 0. In other words, it's negative. You know, we don't know it, but we know that it's negative. How do we know that it's negative? It's because it is a sad graph, and the sad graph is always negative, you know. So they say now we have to look for the range. If y is equals to -f of x, like this, negative. So in other words, let's say f of x, we knew it was, for example, let's say it was negative 2x squared plus 4x plus 3. I'm just giving an example. Né? So if we were to substitute, if we were to put negative there, in other words, we're going to have negative outside and we have something like this, x squared plus 4x plus 3, something like this. And then this negative is going to multiply here and we're going to have positive x squared. So even on this graph, we're just going to have something like that, you know. So if we multiply by the negative, our equation is going to be y, which is equals to negative, the graph, if it is negative a squared plus bx plus c. Why do I say negative? Is because the side graph, we assume that a is going to be negative. So if we multiply with this one, our a is going to be positive a squared negative bx negative c, for example. I'm just assuming, you know. But what I'm trying to say is that a is going to be positive. In other words, if we have negative here, our graph is going to stand something like this, you know. So since the value of a is 3 and 11, you know, so this graph, since it is positive right now, they're going to share the same thing. It's going to be 3, but this one's going to be negative 11, just like that, you know. Perfect. So what will be the range of this graph that is here, that they said as it is now positive? What will be the range of it? So the range of it, we're just going to look at the y-axis. It is this is 5.2. Né? It is y is an element from where it starts from 11, start to exist from 11 until positive infinity. So it's going to start to exist from negative 11 until what? Until positive infinity. So I'm going to put something like this. So now let's just take a look at this 5.3. They say calculate the numerical value of A, B, and C, which is worth 6 marks. That's a lot of marks, guys. So in other words, they're just asking us to determine the equation of this parabola. So to determine the equation of a parabola, the parabola comes in different ways. It depends on what you are given, you know. Yes. So remember, guys, on the previous question, we found that this is 3 and 11. Né? Perfect. So we're given a turning point and another point here. So if we're given a turning point, we're going to use this equation, which is y, which is equals to a over x minus p squared plus q, where p and q are the turning point. You know, we use this one if we're given turning points. So this is a grade 11 work. So we're going to say y, which is equals to a, and then our x. Remember, this one for p is the one that we swap. If it is positive, it's going to be negative. If it's negative, it's going to be positive. So here we have positive 3. So it's going to be negative 3 squared. And then this one remains the same. It's going to be positive 11, just like that. You know, perfect. So from here on here, to find the value of a, we're just going to sub another point. You know, we're just going to sub b, you know. So we're going to sub b. Whenever there is x, we're going to put 6. Whenever there is y, we're going to put 2. So we're going to put 2 here. And then a, 6 minus 3 squared plus 11. So we can say 2 minus 11, which is equals to a. This one, if you practice on a calculator, we're going to get 9. And then this one also is 9, which is equals to a 9, guys. So I'm disabled when it comes to writing a and 9, you know. So this is the a and then this is the 9, you know. I'm going to divide both sides by 9, and then my a is going to be equals to, oh, this one's going to give me negative 9, guys. So 2 minus 11 is negative 9. So this one's going to give me negative 1, you know. Perfect. So how can I find the remaining ones? So to find the remaining ones is very, very easy. Let me just continue this here. So I'm going to substitute this a to the original one. So I'm having y, which is equals to negative 1x minus 3 squared plus 11. Yeah? Perfect. So now I'm just going to expand this one. So I'm going to have negative x minus 3 and x minus 3 plus 11. So this is y, which is equals to, I'm just going to like multiply what is inside the brackets there. X multiplied by x going to give me x squared. Then x multiplied by negative 3 is going to give me negative 3. And then when I add the like term, it's going to have negative 6x. And then 3 multiplied by 3 is going to give me positive 9. And then now I can be able to remove the minus, negative x squared. And then negative multiplied by negative is going to give me positive 6x. It's going to give me negative 9 plus 11. And then y is going to be equals to negative x squared plus 6x. Negative 9 plus 11, let me just check this in the calculator, is going to give me positive 2, Yeah, so A is going to be equals to negative 1, B is going to be equals to 6, and C is going to be equal to 2, Yeah, so we're done with this 6 marks question. So now we can be able to move to the last question. So the last question, they're saying determine the values, which means it's not one value, the values of x, where f of x is greater than g of x, So I want to show you a little bit technique on how to tackle this question, So they want the values of x where f is above. In other words, here they need where x is above, where they need the values of x where f of x, is above g of x. G of x. So how can we find those kinds of values? Let me just erase this because now I hope you have understood how we get it. How can we find those kinds of values where f is above and g is below? It is very, very easy. What you need to do, we are going to draw vertical lines where in the point of intersection where they are intersecting. If you can be able to draw a vertical line, something like this here, So if you can be able to draw the vertical lines where they intersect, now you can be able to interpret this graph very, very, very good, So when we check here, this one is 3, the x values is 3, and this one is 6, So from 3, from the numbers that are less than 3 to the left side, what is happening between these two graphs here? This one and also this one. Which one is above between f and g? You can see that g there is above, So it means that this one, this first one, we don't need it because we want where f is above and g is below, So this one, it has failed. We can move on to the next. If you don't understand this kind of interpretation, I've made a playlist about this. You can check out. You can text this number below. I'm going to direct you to add you to if you want to be enrolled in that kind of a course. Right now, I don't have absolutely full access to give you the links, but I can be able to add you to enroll you if you want to learn how to interpret any graph. Yeah, I have a full course of this. So now we're going to the middle side, between 3 and 6. We want to check what is happening between these two graphs there, Perfect. So the G is going to continue here, and then the other one, which is F, is going to be here. So which one is above another one? You can see that F here is at the top, but G is below. So it means that this one is what we are looking for, But we're not done. We have to look for the rest of the numbers, So the F is going to go that side and then go that side. So we can just look at this graph here. The g of x is above and then f of x is below. It means that even this one, it has failed. We are not looking for that one. We're looking for the one that f of x is above. So the values of x where f of x is above is between 3 and 6, So we can just give our answer here as between, we'll put x here, 6 and 3. So this is going to be our answers for this question. So let's move on to the next one. Okay, so now we're moving on to question 6, So they say given h of x, which is equals to a blah, 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 blah. A is greater than 0 and a cannot be equal to 0. B is negative 1 and 1 over 2 is the point. Okay, B is the point that lies on h. The graph of h of x, which is that one, and then they say 4 and negative 2 is the point on the graph. Okay, And then they say the first question, determine the value of A. How can we find the value of A here? So if you pay close attention to this question, this is an exponential question. Actually, let me just write it here. And then to find the value of A, we just need to substitute this point into our graph here. So we have h of x, which is equals to ax, So we're going to substitute this point that we have here. Whenever there is x, we're going to put this. Whenever there is y, we're going to put 1 over 2. So we're going to put 1 over 2 there, and then here we're going to have a negative 1, So to remove that negative 1, there is a lot of ways to do it, but the fastest way, you can just square root with negative 1 both sides, negative 1 there, and then a here on this other side is going to be equals to 2, So therefore, the first question, the value of a is going to be equal to 2. So the next question there, it says that determine write down the equation of h of negative 1 in the form of y. This is an inverse. They are looking for the inverse of what? Of h of x, How can we find the equation? So it's very, very easy. So now, since we know that h of x, our h of x actually, let me just put this. Our h of x is the same as 2x, Perfect. So to find the inverse, we're going to interchange the x and y. So we're going to put x here, and then 2 will put y on the other side. And then the next thing that we're going to do is just going to log both sides. So we're going to log x, and then we're going to just put this one down y, and we'll log this 2. And we're going to divide both sides by log. I'm just detailing for those who don't understand the logs. So this is going to cancel this, and y is going to be equals to log of 2x. Even if you jump here and write this, you're still going to get the 2 marks, But this that is there is just an understanding of the logs actually, So yeah, we can move on to the next question. So 6.3, they say sketch the graph of h and h of negative 1 on the same set of axes. Clearly show all your intercept, Yeah. So we have the original graph, which is this one that is there. And then now they're asking for us to draw both of those kinds of stuff. So we have if you substitute 0, you're going to get the y-intercept, which is 0 and 1, which I already written it there. So to draw that graph, we're just going to plot that point first. So the first point is going to be 1. So it's going to be 1 actually. And then the second one is this one that they've given us. It's negative 1.5, So negative 1 is here, so half is going to be somewhere. It's going to be somewhere here. It's going to be somewhere here, So this graph is going to go like this, the original one. So this is h actually, So remember, guys, they are reflected with this graph, which is y, which is equals to x. This is unnecessary, but you are just drawing it there. So to draw the inverse is very easy. Just going to just reverse. Remember, this is the same as negative 1 and 1 over 2. And then when we are looking for the inverse, we're just going to reverse this. It means our point is going to be a half and negative 1. So it's going to be somewhere here. And then this one is going to be, for this, it's going to be for this one that is there. And then the inverse is going to go somewhere there, somewhere there. And then this is going to be h of negative 1. We can name our coordinate. The coordinate is going to be 1 over 2, negative 1. Remember, when we're drawing the inverse, we're just swapping the coordinates the other way around, Yeah. So this is it for 6.3. This is the graph that we were supposed to sketch. So now we can move on to the next questions. So the next question that we have there, they say write down the domain of h of the inverse of h actually, So if we come here, and let me just highlight this. So this is the graph of h, So the domain of it here, we check how much does it exist from the x-axis. So it does not exist there from this side, it does not exist this inverse. It exists where x is greater than 0, yes. So how can we say that? So 6.4 is an easy question. It's going to be, it exists in all the element of real numbers, but where x is greater than 0, where x is greater than 0, that's where this graph is existing, where x cannot be equal to 0 because here we have an asymptote, remember, yes, so it is existing where x is greater than 0. So going to 6.5 is a determine the values of x for which h, the inverse actually, is greater than 1, So h, remember, h of x is equals to y. So where y is greater than 1, the y of h of negative 1. So they want the values of x where h of negative 1 is greater than 1 actually, So how can we find those kinds of stuff? To find it is very, very easy. We know that inverse and the original, the coordinate are just swapping it the other way around, We can find what will be the, since this one, let me just rewrite it here. So since this one is the y value, the y value of it is, we don't know the x value, but we know that the y value is 1, So if we want to find the x value, we can just use the original formula. If this point, it want to go to the original, it will just swap the coordinates. The y is going to be here, 1, and then the x is going to be there, which is going to be like the same as y actually when it goes on the other side. So we can use this to find this other equation there by substituting it to the original equation. So we're just going to say h of 1, and then we say 2, 1, and then it's going to give us 2, So on the original, this point is 1 and what? And 2, perfect. So if it is 1 and 2, what will be this point on the inverse? On the inverse, this point is going to be 2 and 1, So this is what this point is on here, So 2 and 1 is going to be somewhere here. So this is 2 and 1 that we have. So what they are basically asking here, they're asking for the values of x which h of x is greater than 1, So remember, this is y, where y of h of negative 1 is greater than 1, So we can just come here and just take a look at this. So 1 is this one, this is the 1, and they want the values of x where this is greater than 1. So all the numbers, let me just highlight this, that from this one downwards are less than 1 when we talk about the y-axis, and then all the numbers from this side to this side are greater than 1 when we talk about the y values, So they want those kinds of x values where this y is greater than 1, So it's from 2 up until infinity. In other words, we can just conclusively say is where x is an element of real number, x, it has to be greater than 2, because from all this side to this side, let me just use the highlighter, all this side that is here, you see, the graph of h of x is greater than 1, the y values are greater than 1, so it is from 2 up until infinity, or we can just simply say x an element of real number where x is greater than 2, So this is it for this one. Let's move on to the remaining questions. So the last question is 6.6. They say that if it is given that the t of x is equals to 1 over 2 x negative 1, describe the transformation from h to t. Don't forget this, that our h of x, is equals to 2x, yeah. So the t of x that we have currently is equals to 1 over 2x, which is minus 1. So they just want you to describe the transformation. How did this graph move from this to this one? Perfect. They just want you to describe that kind of transformation. What happened actually, from this original age to become this one. So if you can pay close attention here, we know that 1 over 2 is the same as 2 is negative 1x, which is minus 1. If you punch this in a calculator, 2 exponent negative 1 is going to give you 1 over 2. So we can just multiply. This is the same as 2 negative x minus 1. P of x is equal to this. Perfect. So what happened actually, the original one graph, it was like this. It was 2 exponent x, but this one, it has a negative, and it also have this one. We know from the exponential that this number that is going to be here is the horizontal asymptote. So first thing, we can first just say, like this graph, it has moved 1 unit downwards because it goes downwards there. So we can just simply say f as shifted 1 unit downwards. Perfect. But it's not that negative one only. We also have negative x there. How did this one become negative? So it becomes negative because of what we call the reflection about the y-axis. Let me just try to just paint a little bit picture about this. So if we have, let's say we have a point here, which is a, and then it's equals to 2 and 3. So this is the x-axis and this one is the y-axis, as you know. So if we want to reflect this point and it comes to this side, if it comes to this at this point here, this 2 is going to remain the same, but the only thing that is going to change is the y value is going to be negative 3. So this is what we mean when we are reflecting a point with the x-axis. So the x values will remain the same, but what changes is the negative. It's the y is going to be negative. But look at when we are reflecting this point A with the y-axis. The point of 3 is going to remain the same, but this 2, when it comes to this side, is going to be negative 2. So what causes any graph to have a negative x or negative y is what we call the reflection about the x and the y axis. Each and every time we reflect the graph about the x-axis, the y value is going to be negative. If we reflect the graph about the y-axis, the x value is going to be negative. If you pay close attention here on this graph, we're having a positive here, but now it has become a negative. So which reflection that has reflect to cause this negative? Obviously, it's going to be the y-axis because that's the only way when we reflect, we're getting a negative on the x value, just like that. So the second transformation that they have made here is that f is reflected about the y-axis. And for this, hopefully you're going to get your full 2 marks. So this is it for question 6. Let's move on to the last question, which is question 7. So here's our last question, which is question 7. This one include trigonometry. So this one it's carried 1 marks on it. So let's just quickly start with 7.1. So 7.1 says that if sine 35 is equals to k, determine the following in terms of k. So they've given us, they say 7.1.1, find determine cos 55. So this one is the cast diagram questions. In order for you to be able to solve them, you need to first draw a cast diagram. Perfect. So we know if we're given, for example, we're given here, which is sine of 35, which is equals to k. So we're going to divide this by 1, and then we use our SOHCAHTOA method. So sine is the same as opposite over what? Opposite over hypotenuse. So we're going to have a triangle like this. And then here we're going to have 35. And then 90 plus 90 minus 35 is going to give us 55. So it means here is going to be 55. And then, yeah. So this one, sine is equal to 35 is k over 1, which means opposite. The opposite of this 35 angle is what? Is k. So the opposite is going to be here. And then the hypotenuse is going to be in this side. So we need to find this missing side, which is the adjacent side. To find it, we're going to use the theorem of Pythagoras. So the theorem of Pythagoras says that r squared is equals to x squared plus y squared, perfect. So the r here is 1, and then the x is what we're looking for, and then y is plus k squared, because when we substitute it there, it's going to give you that. And if you work this one out, you're going to get that your x is the same as 1 minus k squared. So this side here is going to be 1 minus k squared if we use the theorem of Pythagoras, So now we can be able to use this triangle to find the value of what? Of cos of 55, So there is a lot of ways to do this one, You can use this triangle using 55 as your reference angle, but whenever I use this to a lot of my students, they don't understand it in most cases. So I'm going to use the usual way of doing this. So I'm going to expand 55 cos of 55, we can say 90 minus 35, When we say 90 minus 35, it's going to give us 55, yes. So, but cos of 90, this is 90 minus, this is a cofunction. And if it's a cofunction, it's going to be sine of what? Of this angle that is there is going to be 35 there, perfect. So from here on here, we can be able to make use of our diagram. If our reference, and sine of 35 we already have it, yes, equals to k. So it means that our value of cos 55 is equal to k, because sin 35 is equal to k, we're already given there, perfect. So now we can move on to 7.1.2. They say they're looking for sine of 70. How can we do this one? So this one, we have two ways to do it. We can do it by using the compound angles or double angle, because if you just take your calculator there and you say 2 multiplied by 35, it's going to give you 70. Or if you say 35 plus 35 is going to give you 70, So we can do it in any way that we like, but I would like to do it using the compound angles, whereby I'm going to just say sine of 35 plus 35. When we add these two, I'm going to get 70. And from here on, I'm going just to use my compound angles, So which compound angle am I going to use here? Let me just bring these kinds of formulas here. So yeah, here are those kinds of formulas. Of cos of sine, the one that is positive. It means I'm going to use that one. I'm going to use this one actually, this highlight is two. Yeah, this one, I'm going to use this one. So sine is going to be sine cos and cos sine for the compound angle. So from here on here, look what I'm doing, man. So it's going to be sine of 35, the reference angle, and then cos of 35. You can do it in any way. You can use the double angle any way that you think is fast. You can use it. So plus, and then here is going to be cos of 35. And then sine of 35, perfect. So what is sine of 35? We know sine of 35 is equals to k, so we can say k. Let me just remove this. We can say k. And what is cos of 35? Cos of 35 we've been found, but we can use this triangle that we're given here. So if our reference angle is here, this is going to be the opposite, and this is going to be the adjacent, and the hypotenuse there. And then cos, we know using the Socrator method, is adjacent of hypotenuse. So our adjacent here is going to be what? It's going to be the square root of 1 minus k squared. And then the hypotenuse is going to be equals to 1. So in other words, cos 35 is the same as root of 1 minus k squared. So we can just substitute it there. So for cos is the same as root of 1 minus k squared. Then plus cos of 35 again is the same as what? As the root of 1 minus k squared, because they're still the same. And then sine of 35, we already have it, is equals to k there, perfect. So from here on, we just need to simplify this. So this is going to give us k root 1 k squared, which I'm unable to write 2. So plus, and then even this one's going to give us k over 1 minus k squared, because we are multiplying a variable with a sets, actually, So the rules of sets, they say that if we are adding sets, we're going to just add these numbers that are here. So k plus k is going to be what? It's going to give us 2k, and then this root are going to remain the same, 1 minus k squared. So this one is going to be your answer, So in order for us to move to the 7.1.3, I'm going to just erase all of this. You can just take a look at it for the last time before I erase it, because I want to have enough space to write this. Okay, so cos of 80, which is 7.1.3, how can we find the value of this one? So if you pay attention, cos of 80, how can we expand this cos? Let's just write it cos, then we open these brackets. Which two numbers that we can be able to add them together is going to give us 80. And one of those kinds of number, it has to be 35. And the other number, it has to be a special angle if we add it, or it's a cofunction or a reduction, So if we add 35 with 45, you're going to get 80, So we can just simply say 45 plus 35, perfect. So 45 plus 85 is going to give us 80. And from this one, we can also use the compound angle, but this time around, we're going to use this one because it's cos of plus. So we're going to use cos, sin, which is the compound angle. Perfect. So here we're going to have cos of 45 and then cos of 35. And then the sign is going to change there. We're following this. Don't forget, don't worry, they're going to give you this kind of formula sheet in your exam. And then it's going to be sine of 45 and then sine of 35. This one, the next one. And then from here on, cos of 45, you can just press this in a calculator. If you put your calculator, cos of 45 is the same as root 2 over 2. Perfect. So we can put this inside the brackets. And then cos of 35, we just calculated it. We can just use this. It's the same as root 1 minus k squared, perfect, because it's the adjacent over hypotenuse. So this is it. And then from here on, let me just make it a fraction so that we can be able to multiply very well next. And then sine of 45 is the same as root 2 over 2 if you put this in a calculator. And then sine of 35, we already have it is k. So I'm going to just make it as a fraction so that I can be able to multiply very easy. So then 2 multiplied by this one is going to, what can we do here? Here we can take out the common factor actually, or we can multiply, it's up to us. But we can take out the common factor because here we have this and also this one. Or you can multiply this root 2 with this one, but that one is going to take very long to do. So I'm going to go with the easy one. I'm going to take this square root of 2 over 2 as a common factor. And then if I take it, I'm going to be left with this one. So it's unnecessary for us to write the ones because I'm going to use it. 1 minus k squared. And then when we take this one here, we're going to be left with negative k, So 7.2, it says that if sine of x minus cos of x is equals to 3 over 4, calculate the value of sine 2x without the use of a calculator, So how can we solve this question actually? So I've seen this question and I try all the other ways to do it, but it seems like it does not it does not help me to find how can I find this kind of sine of 2x actually that they are looking for there. So these type of questions are the ones that when you want to solve them, you need to use that method of squaring both sides, So here on this question, we're going to square this sine x minus cos of x. And we also square the other side of 3 over 4, square it just the way we did on the other one, After we square both sides, we can just expand this. It's going to be sine of x minus cos of x and sine of x minus cos of x. And then this one, if you punch this one in your calculator, you're going to get 9 over 16, because that one is going to give us 9, the other one is going to give us 16. So we can just use the law of distribution. Sine x multiplied by sine x is going to give us sine squared x. And then sine x multiplied by cos is going to give us a sine cos, negative sine cos. And then if we add, okay, let me just go easy, it's going to give us sine x cos x. And then even this one is going to give us negative sine x. And let me just write it correctly, sine x cos x. And then negative cos x multiplied by negative cos x going to give us positive cos squared x, which is equals to 9 over 16, Perfect. So from here on, next, what we're going to do, we're just going to add the like terms. So we're going to have sine squared x. And then these are the like terms going to give us negative 2 sine x plus cos squared x, which is equals to 9 over 6, not 19. It's going to be 9 over 16, not 6. Perfect. So now we can be able to see that this sine 2x is going to come from this one that is there, because it's the double angle. And then if you pay close attention, sine x multiplied by sine squared x plus cos squared x is going to give us 1. So this is the same as 1. And then minus 2 sine x cos x, which is equals to 9 over 16. And then this one that is at the top, this one is the double angle, So it's going to be 1 over sine 2x, which is equals to 9 over 16, Perfect. So from here on, what can we do to find the value that we're looking for? We can just take this one to the other side, 1, and then we'll take this one to the other side. It's going to be 9. You can do it in the other way around. So it's going to be sine of 2x, So now we can see that the sine of 2x is equals to what? Is equals to this one. So we just have to punch this in a calculator. So I'm going to finish it here. So sine of 2x, if you went and punched this in a calculator, going to get, it's going to give you 7 over 60, So this is the value of what? Of sine 2x that we have found without the use of a calculator. Let's move on to the next question. So 7.3, they say simplify to a single trig ratio. So this is a simplified question. So I want you to notice something about the simplifying of the trig ratios. There is something that does not change each and every time. If you take out there is this maths app that you can find on Google, on App Store, or Apple Store. There's this app of maths. If you go to that kind of an app and you go to that kind of topic of trigonometry, you look for each and every question that talks about simplifying. There is something that is there that will give you a lot of clue. So each and every question, I want you to go take your phone right now and just check those kinds of questions on your app. Go to trigonometry, look for each and every question that talks about simplifying. All the questions that say that simplify into a single trigonometric ratio. At the end of those kinds, if you check the memo of each and every question, you're going to find that their answer that they're getting there, it's either is sine of x or cos of x or tan of x, or they get something like cos squared x or tan squared x, or like they get a single trig ratio, they get a certain trig ratio that they found at the end of the day whenever they say simplify into a single trigonometric ratio, you know. And I also wanted to just check this one whereby they say simplify into a numerical a value, you know. All those kinds of questions, at the end of it, you're going to find that at the end of it, you're going to find a certain number. It's either is 2 or 1 or 3 or -2, something like that, you know. So if you are aware of that, you're going to like solve your question with intentions and knowing what you're going to get. So on this question, hopefully when we are solving here, we're going to get a single trigonometric ratio, not going to find any number, you know. So this is just a guidance or a direction for you to understand that if you get a certain number, it means you didn't simplify in a good way, you know. So yeah, I've been doing a lot of flipping. Let's just focus on the question right now. So how can we simplify this one? So this is very, very easy, but it needs you to be very, very careful. Yeah? Perfect. So tan of 180 plus x, this is found in the third quadrant. Yeah? So this one is going to be equals to tan x. Tan x. How do we know? Is because this is found in the first quadrant, in the third quadrant actually. So you need to know all those kinds of stuff. So cos of 360 minus x. This one is also found. Let me just use the brackets because yeah, that one is the easiest one. And then this is going to be cos of x divided by, so sine of x minus 180. This type of questions, guys, you cannot find them in your diagram. So let me just try to just make you understand what is happening here. Minus 180. So if you're struggling with this, it's very, very easy. What you need to do here, you just need to add 360 to just put it in a way that is going to be in such a way that you're going to understand it. So I'm going to have x minus 180, and then you can add 360 for this. So if you add 360, you're going to have x is going to give you a 180. When you add this one, this two is going to give you what? A plus 180. And then from here on, we can just flip this one. We know 2 plus 3 is the same as 3 plus 2, right? Yeah, so we can say 180 plus x. So in other words, this is the same as what? As this thing that is there, you know. So knowing that, we can be able to like now interpret it. So where do we find 180 plus on our diagram, on our cast diagram? 180 is on the third quadrant, which is sign is negative. So here we're going to have negative, here we're going to have negative sine of x, and then cos of 90. This is a cofunction, guys. So but cos of 90 is found where? In the second quadrant, you know. Cos of 90 plus theta or x is found in the second quadrant. So but when we talk about 90s, guys, we're talking about the cofunctions whereby the cos has to change to sine. So this one is going to be a negative sine of x, you know. Why is it negative? Because cos on the second quadrant is negative, you know. Perfect. So we're going to have plus, and then sine of cos of 720. How can we find this? If you can pay attention, we don't have this in our diagram actually, but how can we solve it without having it in our diagram? So this one also can be able to just like simply subtract 360. If we can subtract 300, and there is a lot of ways to do this. Some other people, they can be able to like figure it out how is cos going to be negative or positive, but for those who don't understand, we're just going to do it in that way. 720 plus x, we're going to subtract 360, and then we're going to just subtract 360 for this. So we're going to just put that one in your calculator. So 720 minus 360 is going to give you 360 plus x, you know. Perfect. So 360 plus x is found on the first quadrant where cos is positive. So here we're going to have cos, which is positive, cos x, perfect. And then cos of negative x, negative angles, all the negative angles is the only trig ratios that is positive on the negative angles is cos. So here we're going to have a cos of x. Let me just make this one a little bit big. So yeah, now I think out of these 6 marks we almost have 4. Yeah, almost have 4 marks for this one. So next we can just expand this term. This is the same as sine of x over cos of x. And then here we have cos of x over 1. We want to just multiply this. Remember, we're going to put the bigger brackets, and then sine x multiplied by negative sine x multiplied by negative sine is going to give us sine squared x, plus, and then cos x, this is going to give us cos squared x, perfect. So now we just need to make sure that we take care of the decimals that are there at the top. So here I'm going to detail for those who don't understand. So this is multiplication. So sine multiplied by sine is going to give out, they are cancelling each other out, but there's these students who don't understand this. So this is going to give us cos x. Cos multiplied by 1 is going to give us cos x there. Remember, we have a bigger bracket. And this is too long. What the fuck? So sine squared x plus cos squared x, this is equal to 1, yeah. So then which means we're going to be left with that 1. So this is going to cancel with this, and then we're going to be left with sine of x, which is divided by 1 there, which this is going to give us sine of x. So I want you to pay attention here. They say that we must simplify into a single trigonometric ratio, and this is a single trigonometric ratio that they were looking for. So we can move on to the next question. So 7.4, they say prove the identity, which is this one that is there. You can either prove that this side is equal to this, or you can prove that this one is equal to the other side. You can pick any one that you like. But what I will advise you always, you have to choose the side that if you choose it, you're going to change a lot of stuff there. If you can pay attention to these two sides, which is this one is the left, this is the left hand side, and this is the right hand side. If you pick the right hand side, you can only just change this one. Yeah, you can change this one and this one, and nothing that you can do there after changing that one. So I would advise you to always pick the side that you're going to change a lot of stuff, because in proving identities, these 4 marks that is here, a lot of those kinds of marks are going to come from you changing some certain. You're going to get those kinds of marks on how many trig ratios that you have just changed there. Yeah. So the left hand side is the safest. Why? Is because we're going to change a lot of stuff if you can just pay attention to it there. So we're going to pick this left hand side. Perfect. So on the left hand side, we want to make sure that this thing that is on the denominator, we have to get 1, and then on the numerator we have to get this cos squared x. What can we do? So here we're going to just make use of our double angle. So the double angle, there's a lot of double angles here. Let me just bring you the formula sheet. So here's the double angles that we have. So which one can we pick that is going to give us 1 there? So if you pay close attention here, if we pick this first one, it's just going to complicate things because we're going to have a lot of trig ratios. So what you need to do, you have to make sure that everything that is here, they are the same. Yeah. So to make this the same, we already have cos squared here. If we can change this double angle into this one, we're going to have cos also. We can change this sine squared into cos, and then we're going to just have the same trig ratios all there. Yeah, perfect. So this cos, we're going to just change it into what? We're just going to change it very easy into 2 cos squared x, which is minus 1, and then plus, and then this one we're going to just keep it the same, x, and then plus 3. We're going to change this sign squared into 1 minus cos squared x, which is divided. So downwards here, if you pay close attention to this one that is down, we can take out the common factor there. The common factor, something that is common between these two terms, is 2. So we can take 2 out, and then you're going to be left with 1, and then on the other side, we're going to be left with sin squared x, just like this, perfect. So yeah, if you can pay close attention also here, this is the like term of this one because they both have cos squared and this one have cos squared. So if we add them together, they are going to get 3 cos squared x and then minus 1. And then this one we can just distribute it here and also here. And then we're going to have plus 3. And then 3 multiplied by negative cos squared, this is going to give us negative 3 cos squared x divide by, so you're going to have 2. So this is the same as what? As cos squared x. So you can see right now that we are getting closer to get this cos squared as soon as possible. And then if you also pay close attention here, these and these are the like terms that are going to cancel each other out. So it means there at the top, we're going to be left with what? We're going to be left with negative 1 plus 3 divided by 2 cos squared x, perfect. So negative 1, this is, let me just put equal sign so that it can be able to be understandable. Let me finish it here. So negative 1 plus 3 is going to give us 2 divided by 2 cos squared x, So these two are going to cancel each other out, and then at the top we're going to be left with 1, and at the bottom we're going to be left with cos squared x. So as you can see, this left hand side is equal to the right hand side. So we can just do our conclusion, because the left hand side is equals to the right hand side, and we are done with this 4 marks question. So moving on to 7.5, they say determine the general solution of 2 sin x cos x minus cos squared x, which is equal to 0. And this one is worth 7 marks. That's a lot of marks, guys. So here we're given this equation, which is this one. So if you can pay close attention, between these two terms, we have a common factor. There is something that is common here. So cos is here, and also there is cos. So we can take that cos out. So we're going to have cos x out. And if we take cos x here, we're going to be left with 2 sine of x. And then here, if we take 1 cos, we're going to be left with minus cos x, 1 of it, which is equal to 0. So what is here? This is the same as when we have something like this. When we have 2, let me just give you an example. When we have x over x minus 1, which is equal to 0. How do we solve for x here? We're just going to say x is equal to 0, or x is going to be equals to 1. So this is what we're going to do basically even on this one. We're going to apply the 0 factor law. So cos of x is going to be equal to 0, or let me just write it here, or 2 sine x minus cos x is equal to 0. So it means that we're not going to have one general solution, we're going to have many. So from here on, this one, it means that we're going to look, I'm talking about the first solution because we have 2 of them. For the one of cos, we're going to look for a general solution where cos is positive, So first things first, we're going to look for the reference angle. So the reference angle is the one that we're going to just to say x is going to be equals to, I'm just going to press cos of negative 0. You're going cos inverse, and you put this 0 that is there, and it's going to give you the reference angle. So if you want that one and punch in your calculator, you're going to get that the reference angle you're going to have 90. Perfect. So this, it also means that we're going to look for our general solution where cos is positive. So cos is positive where? cos in our quadrant is positive on the first quadrant and also on the third quadrant, So if we're looking for a general solution where there is positive, it means that the reference angle is going to be our first solution for the a general solution that we're going to have here. Let me just repeat that again. When we're looking for the general solution of a certain trig ratio, and then we're looking where that kind of a trig ratio is positive, the reference angle is going to be your first a general solution, So it means that here our first general solution is going to be x, where is equals to 90, and then plus k 360 k element of integers, perfect. So this is going to be our first solution, or our second solution, we're going to find it where x is positive, where is 360 minus, so we're going to have x, which is equals to 360 minus what? Minus the reference angle that we have, minus 90 plus k 360, so this is going to be x, which is equals to 360 minus 9 is going to be 270 plus k 360 k element of integers, so this is our first solutions that we're going to have, so let's just move on the other side and try to solve the other side that we have there. So here we have 2 sine x minus cos x. How can we solve this? Here there is still a lot of work that we need to do. So we can take cos to the other side. So we're going to have 2 sine x, which is equals, this is going to be positive on the other side. And we can divide both sides by sine of x and then sine of x. So this is going to cancel this, and we're going to be left with 2. And then this is the reciprocal of tan, so we're going to have 1 over tan x. Remember guys, sine x over cos x is the one that is equals to what? To tan x. But if the cos is at the top, it means it's going to be 1 over tan, so we can just cross multiply this. Tan 2x is going to be equals to 1, and we can divide both sides by 2. And then tan of x is going to be equals to 1 over 2. So in other words, we're going to look for the general solution of tan, actually, yes, because our main goal was to make those those trig ratios have the one trig ratios at the end of the day. And then when we do that, we're going to find that tan is the only trig ratio that stand out there. So I'm going to just erase this a little bit and be left with one thing there. So to find the general solution of tan, we need to first find what we call the reference angle, So the reference angle is very easy. Just going to on your calculator, take a calculator, just say a tan inverse, you put that 1 over 2, tan inverse, and you put 1 over 2. So if you went on your calculator and punch that one, you're going to get that tan inverse of 1 over 2 is going to give you 26,5. Let me just round it into 2 decimal places. 47 there. This is going to be our reference angle. So now that we have our reference angle, we need to understand that we're going to look for the general solution where tan it is positive, So tan it is positive where? If we have our cast diagram, it is positive on the third quadrant where 180 is plus, and then also here, on the first quadrant. So whenever we're looking for a general solution where any trig ratio is positive, it means that the reference angle is going to be our first general solution. So the first general solution is going to be x, where it is going to be 26,57 plus k 360 k element of integers, Or the second general solution that we're going to look where cos is positive on this one and also on the third one. So the third one is x, which is equals to 180 plus the reference angle, which is 26,57, plus k 360. Remember, we don't put k element of integers if we're not done solving. So we're going to have x, which is equals to 180 plus 26 is going to give us, let me just check this one. It's going to give us 206,57 plus k 360 and then k element of integers. Yeah. So this is it for this video. So thank you so much guys for watching this video until the end. If you found something useful in this video, you can subscribe to the channel for more of question papers, and you can comment below what question papers that you would like me to do and what other concept that you would like me to cover. So see you on my next video. Sharp.